Okay, LeetCode problem 572. Subtree of another tree. Given the roots of two binary trees, root and subroot, return true if there is a subtree of root with the same structure and node values of subroot, and false otherwise. A subtree of a binary tree is a tree that consists of a node in tree and all of these nodes' descendants. The tree could also be considered as a subtree of itself. Okay, so we have a big tree and we're trying to find the little tree inside of it, and the value should be the same. So in example 1, we have the big tree with its head at 3. 3 has 2 children, 4 and 5. 4 has 2 children, 1 and 2. And then the subroot we're trying to get is 4 with the children 1 and 2. So we have this in here. So this would return true. Second one, we have 3 had 4 or 5 children. 4 has 2 children, 1 and 2, and 2 has 1 child at 0. We still have the same 4, 1, 2, but it's going to return false because the 2 has a child of 0. So let's see if there's a subtree of root with the same structure and value of false otherwise. Subtree of a binary tree is a tree that consists of the node and tree and all of its nodes' descendants. Okay, so that's why. Example 2. Okay, so we need to do some kind of comparison between our root and our subroot. I know we're probably going to need a second function to go over the left and the right and compare those. So this big function will just compare the trees, and then we'll use left and right. We'll also compare the values. So we need to compare the values and then the left and the right. But I think we're going to need another function to do all of that. And then, so let's start off by doing our guardlet, since it's optional. Guardlet root equal root else we return false. Guardlet, okay, return false. And then we're gonna use recursion, so we can just do return. We're going to return a subtree. We're going to just do root dot left subroot. Or a subtree. Do the same thing for the right side. Okay, and then we're going to need we're going to need a function. We're going to need a function to check if the two trees that we're working with are the same. So, I mean, it's going to be the same as this function, but our conditions are going to be different. So we can do is tree same. Tree node. Then we'll pass in our subroot as well. There's also a tree node. And then we're gonna return a bool. Okay. Okay. All right. Okay. So what do we want to do here? We want to check if their two are the same. We can do if else. If they're both null, they're the same. If one is null, one isn't, they're not the same. And then we need to also check the values. Okay, probably not use root. What can I use? It's A and B. We can use if. No, let's do a switch. Let's do a switch instead. Let's do a switch. We can do a switch like so. We do a case. And then we can return false. If they're both empty, we return true. If they're given, okay, so yeah, we'll return true because they're the same. And this would be no, nil. And then our second case will probably be a lot more in depth. So we can do this. And then let's just get the default out of the way. The default is to return false always. Okay, so here we want to probably get the values. So we can do something like a this is such a lazy way to do it. I'll probably false unwrap it. Well, I mean, not force unwrap it, safely unwrap when I'm done. And then this will return false. I know we can use recursion. Okay, let me do this correctly. Because we can recursively use this. as our return. And then we can pass in our left and rights here. Same. Okay. And is tree same. So in here we'll do our lefts. Let's see. Am I doing this right? Because I feel like I'm not. B left. We can do a right. Okay. And then we can probably add to this right here. Or we can use the tree same, and then we will pass in our root and our subroot. Okay. I'm sure the problem's gonna be in my second case. Let's run it and see. Expected. Okay, that's not very helpful. I mean, it is helpful, but it's not gonna. Our expression of pattern bool cannot match of types tree node in a solution. No, return true. Our expression of pattern bool cannot match. Okay, let me do it the correct way, because I don't want to go too deep. So we can do something like this. Again. And let's let a tree, should I make it? Yeah, it's gonna be optional. I'm gonna let b tree. And then we can do where, right? Where a tree's value, and that's what I was doing, is equal to b tree dot val, and then we can do return, and then we're going to do is tree same, and is tree same. And now we can just use these values here. So we can do a tree left, and a tree dot right, b tree dot right. Okay, this should work. Cannot find its subtree. Okay. Cannot find subtree. subroot, not subtree. And there we go. Both test cases pass. Okay. So let's go through it again. We have our guard because our root is optional. So we want to safely unwrap it because it couldn't be nil. And then we have our, what this we call like a nested function, a function inside of our function that just checks if our two trees are identical. It takes like our nodes, or it takes our tree nodes and then returns a bool, like just like the OG function. And then we do another check if both cases, if both trees are empty, nil, they are identical. They're both empty. So here we're trying to check if they're in the same structure and if the values are the same. And then we're also safely unwrapping them because once again they are optional. And then default return false, so that it looks like we're checking all our cases. So if one is nil and the other one is nil, it'll fall to default is false. I mean, they're not the same. If they have different values, it'll fall to default because they're not the same. Okay, so then we return. So this one we're checking if the head is both the same. And then we're checking the left subtree. We're checking if our subroot exists somewhere on the left, and then we're checking if the subroot exists somewhere on the right. So that should work. Let us submit and see if we fail any test cases. All right, we're not the fastest, but I mean, we're somewhere in the top percentile. All test cases passed. All right, that is problem 572, subtree of another tree.